and welcome to this predictive data mining demonstration of high yield prediction in sugarcane plants or crops. Now, for a good sugarcane production, there are certain prerequisites. For example, the nitrogen content should be mixed with soil by 30 to 50%. This is the whole data set is been acquired from agricultural department and is standard data set. The drop irrigation is required by this. Traditional drip irrigation is required of this much percent. Traditional irrigation is required by this person, and this whole data set is of 1 acre of land. How much time the vitamin should be sprinkled, and what is the total water requirement for 1 year, and in order to avoid disease of the sugarcane, how much Asiphate should be included. So this is the standard data set. Now beside this, we have acquired several years weather data set from the weather department. So as you can see, we have several month-wise data of maximum temperature, humidity, rainfall, and the wind percentage. Now based on this parameter, we need to do two things. We need to first predict the productivity of the sugarcane plant on this environment, and then we need to calculate the prerequisite. That means if this is the weather, then what percentage of Asiphate should be mixed with the crop, and what percentage of what is the water requirement that we should put. So from the weather, we need to predict the the crop productivity, and at the same time we need to also predict the extra water that would be required for this month. So this has basically two parts. First, having a prediction of the disease of the crop, then second, make a model of the parameters, and then to predict what is the requirement. This project is developed using Java, NetBeans. Now first would be loading the training data. The training data is a rule set. Now this rule set is the observed data being acquired from the agricultural department. What this data does, so I'm going to introduce this rule data. Now what this rules data does is, we have acquired that under what condition, what is the disease content or disease percentage that is being observed, under what humidity, what percentage of disease is being observed. Now just as a observation, you can see when the humidity is higher, the disease also seems to be quite high, and is hardly, and under high windy, high humidity and high rainfall is invariably we find that the percentage of the disease is high. So this data has been put together into simple graph over here. However, if we see, because the data range of all these four fields differs a great deal, the variation in the graph is quite high. So what we do is we first normalize the data, and then we filter the data using principal component analysis. Now once we filter the data with principal component analysis, you can see the data is much more correlated, and the variation of the range gets reduced. So this is much more correlated data over here. Now we use a tree based classifier over here. So what we do is we prepare the data for the classification. Now what it does is, this tree based classifier, it requires the class to be labeled. So based on these parameters, we convert the possibility or the percentage of disease as very low, very high, medium, and so and so. So based on this PCA data, we classify this data, we pre-label this data. So very low, low, medium, high, very high. Now it forms basically a 5-leaf node where the 4 leaves will be of the weather parameter, and the 5th one is the output or the class leaf, which is the label. Now the objective of this whole Java based module is to take the month's temperature as input, filter it with principal component analysis, and then classify each date's data with this tree-based classifier to know what every date results in, whether it results in low predictability, low error, high low disease, high disease, whatever. Now if the disease is low, productivity probability is higher. If the disease probability is higher, predictivity is low. So let's just now load the test data. Now from the weather data set, let's give August data as input. Now from the August data, using total rainfall, we first calculate the possible rainfall for the month. So total rainfall for the month for 1 acre of land is predicted to be 315 liters. Now based on this prediction, we can now predict how much extra water would be required. So we have loaded this raw test data. Let's filter this data. And you can quite well see that it's a high humidity, because August is more specifically a rainy month, so humidity is quite high. Let's filter this data. So this is our filtered data, and now let's just find the yield. So when we click on finding the yield, every day wise it's going to try to find out what is the percentage of yield. Now because month of August is quite heavy rainfall and humidity rainfall, at many days the possibility will be low, because the percentage of disease will be very high. So once we aggregate the whole month's data, we can see that the predictability for this month, if we assume the conventional agriculture, would be about 77%. However, we can enhance the possibility of this yield, and that's how we can do that. Now if we go for calculate requirement, we can see conventional watering 95% would be required. So now in general, the rule says that the conventional water that you require would be 95% of the whole requirement. So here it gives around 95.31%. Drip irrigation required would be 65.21%. Drip irrigation would be around 65.21%. Asiphate required would be 16.93. Now look, in normal, if you follow the traditional agriculture, you'd have used a 75 ppm, but this particular predictive mining technique is going to tell you exactly what percentage or what quantity of Asiphate you should be mixing. So in the month of August, rather than 75, we should mix 16 in per 1 liter of water. Vitamin and nitrogen 30 to 35%, 30 to 50%, zinc to 20%, and potassium to 50%. So the project links that the effect of vitamins, nitrogen and zinc has got nothing to do with the weather data, and this is not correlated. So by seeing this, you can then form your data. Now if you take the data for any other month, say for example I'll be going in the month of April, or say for instance let's go with the month of February. Let's go with the month of February or any other month, say. The total rainfall of 1 acre of land is predicted over here. Based on that, let's filter the data and then try to find the yield. So once we try to find the yield, it shows that the sugarcane productivity in the month of February is quite high, and as high as about 93%. And if we go for the requirement, it shows that the conventional watering required for this month, because the observed rainfall was quite heavy in the month of February, so it shows that the conventional watering required would be only 10%. Compare this finding with our conventional data that is being provided by the agricultural department. So we would have traditionally used 95% of water. Instead of that, now we'll be using 10% of water. So we exactly know how much percent of water we should be using as far as the irrigation is concerned. And the Asiphate, which I would have used, farmer would have used 75 ppm per 1 gram of water, now be used to only about 5%. So that gives you an optimized requirement. If you follow that, you could enhance your productivity to great level. I hope you enjoyed this data mining, predictive data mining work of ours. Thanks for watching. Thank you.